What's going on, guys? Welcome back to actually our last video for upper bound calculus. I know this semester went by quick. Well, in this video, I just want to cover all the things you will see on your post test. I know we talked about, I think it was tangent lines, the very first class, and also rate of change, but that will not be covered in the post test. So make sure you know how to evaluate limits graphically for limits and one-sided limits. Make sure you know how to compute limits of polynomials and for limits of rational functions. Remember, for those rational functions, we learn different methods. So we'll look at that in this video today. Let me move this out of the way. Perfect. So limits graphically. So given just some graph, make sure you know how to calculate the limit. In this case, I have the limit as x approaches 5 of this graph of f of x. Let me get my little laser pointer. Sweet. Limits do not care about what's happening at x equals a, but only what's happening around x equals a. So my a in this case will be a value of 5. So positive 5, awesome. Let's see what's happening on the left side of 5 and the right side of 5. If those two are equal, we're good. That means I can actually evaluate my limit. If the left-hand side does not equal the right-hand side, I have a problem. My limit does not exist. So the left-hand side of 5. What do I mean left-hand side of 5? The values that are smaller than 5. Right-hand side means greater than that. So here, the values that are less than 5 are going to be these values here. So as this starts to approach 5, looks like we're approaching negative 1. Okay? So left-hand side is going to approach negative 1. You can think about that. What about the right-hand side? So the right-hand side, again, the values are bigger than 5. So as these values start to approach 5, we're approaching negative 1 as well, which is great news because our left-hand side and our right-hand side are equal to each other, which leads us to say that this is going to be equal to negative 1. Again, if our left-hand side and right-hand side are not equal to each other, then that's a problem. So, with that being said, let's look at this next one. The limit as x approaches negative 1 of f of x. So, let me get my laser pointer. X equals negative 1 right here. Try left-hand side, try right-hand side, see if they match up. So left-hand side is this part right here. So as we approach negative 1, looks like our output is approaching negative 1. Okay, so think back to that think it in your back of your head. That was a weird sentence. What about your right-hand side? So all this stuff, as this starts to approach negative 1, ooh, our output is approaching 4. So since the limit as x approaches negative 1 from the left does not equal the limit as x approaches negative 1 from the right, we're going to say that this limit, move my character out of the way, does not exist. It doesn't exist because the limit from the left-hand side and from the right-hand side do not equal, which is what we need in order for it to exist. So speaking of left-hand side and right-hand side, we're going to calculate this. Remember our notation? It's this little negative for left and then a plus sign for right. So this talks about the values that are less than negative 4. So here's our negative 4, so it must be these values right here. So as this graph, or this part of our graph, starts to approach negative 4, looks like it's approaching this negative 4 for our y value, which will lead me to say that the limit as x approaches negative 4 of f of x is equal to negative 4. And then when we go from the right side, so looks like we're approaching 3 this time. Again, right side means numbers that are bigger than 3. So this part of our graph here, as we approach x equals 3, looks like we're approaching 5. So in this case, it will be equal to 5. Notice here, if I was to ask what f of 3 would be, our f of 3 would be 5 as well in this case, solely because we have a closed dot. Yes, we have a closed dot and an open dot here, but our closed dot has more, not only more value, but has more importance. I'm trying to think of the word to say there, but we're going to go with our closed dot there. Now, for polynomials, we looked and we saw those 9 different properties of limits that allow us to compute polynomials. So while I would not be requiring you to show your work, if you want to, you can take this polynomial and break it up into 3 separate limits, and then take those coefficients out and make them as a constant out front, and then just evaluate them using rules, I think it was 7 through 9. That's legitimate and that works. However, we saw, I think it was a rule that said that limit as x approaches a of f of x, we can say f of a, given that f of x is nice enough. Now, that term nice enough is pointing to a thing called continuity, which, again, we haven't discussed. But for the most part, we said, hey, Mr. Garcia is not that mean, and we know that polynomials will be continuous or nice enough. So in this case, I have a polynomial. We're good, we're safe. So if you want to do limit properties, totally fine. If not, I recommend just plugging in 3 every time you see an x. And from here, either use just mental math. Oh, that's a 3, that's not 14. Mental math or just a calculator, doesn't matter. I believe you should get 30. Yeah, 30. Cool. So nothing too crazy there for polynomials. For rationals, again, all depends on if you think I'm mean or not. But if you have something like this, where it's 2 polynomials, one on top and one on bottom, it's actually the same thing as we just did. Now, given sometimes you have a situation like this, where I try to plug in my value of a, and if I was to do that here in this case, if I was like to plug in a here, we get something really bad, which we don't like. We get 0 over 0. And we call that an indeterminate form. We don't like dividing by 0, and especially we don't like 0 over 0. So we saw that we can mess around with this function, and we can see how we can reduce it. Well, we saw that. Let's try factoring first. And then we also learned a different method, which you'll see here in a second. So factor the numerator and factor the denominator. We can take out an x on top, and we can take out an x on bottom. And hey, you got an x on top and x on bottom. That's great news, because what we can do now is just cross out those x's. They can cancel out. And so now we're getting the limit as x approaches 0 of x plus 2 over x plus 6, which is great news, because we could just plug in our value of a in this case. And again, just housekeeping things, and then that'll be our answer. Notice that I kept writing my limit sign and my x approaches whatever until I finally actually evaluated my limit at x is approaching a. Just to make sure we're understanding. Yes, I know that might be tedious, but that is something you need to get comfortable with. Sweet. So now we have limits for rationals. We're going to compute the value of this following limit. Limit is x approaches 6 of x squared minus 36 over x squared minus 3x minus 18. So we're going to use the fact that we can factor. And one thing on top, notice here, and I'm going to write my limit sign because I will forget it. We have a difference of squares. So if you remember, our difference of squares is going to be a plus b and a minus b. And we're actually going to use that fact on this next couple slides. So with this here, on top, we're going to get x plus 6 and x minus 6. And on bottom, We're factoring with an a value of 1. If you forgot how to factor, I have some videos actually on this channel of me showing you how to factor when a equals 1 and also when a is greater than 1. So make sure to check those out if you're struggling with factoring. If you're not struggling with factoring, you should have got x minus 6 and x plus 3. Boom, boom. We get our 6's to cross, or our negative 6's to cross out. Now we get this limit as x approaches 6 of x plus 6 over x plus 3, which is great news because now what we can do is just plug it in. So we get 12 over 9, which again divide that by 3, which would be a good 4/3. So with our limit, or sorry, with our function that's rational, yes, we will have a hole at 6, but my limit doesn't care what's happening at my a value, only what's happening around the a value. So around the a value, it looks like the left-hand side and the right-hand side are approaching 4/3. So that fact I used last time, x squared minus b squared equals a plus b and a minus b. That's actually going to come in handy this time. So notice here I have the limit as x approaches 7 of the square root of x plus 2 minus 3 over x minus 7. Excuse me. So with this here, it's not really intuitive of factoring. You can't really factor the top or the bottom. So the next method we learned was multiplying by the conjugate. So I recommend multiplying by the conjugate of our numerator. It won't really help us to multiply both sides by x plus 7. That won't really help us. But we're going to multiply by this conjugate over root x plus 2 plus 3. Now notice here on the bottom, I'm not going to multiply that out. I'm going to leave the bottom alone. Just don't mess with it. A lot of times you'll see in just different algebra classes how teacher always, well, which makes sense since you're just learning the basic rules and building blocks of algebra, then whenever you have two binomials, you must always multiply them together. Well, not necessarily true. In this case, it actually wouldn't help us to multiply our denominator out. But for our numerator, this is going to be nice. It's going to be good because if you notice, it's actually very similar to what I wrote up here. So if it helps you, I will label what's A and B. This is A minus B, and this is A plus B, which is great news because, yes, if you multiply them, you'll still end up with the same thing, but just plug it in to the A squared minus B squared. And I'll work it out probably down here. So our little A squared minus B squared is going to be the square root of x plus 2 squared minus b squared, which b in this case is just going to be that value of 3. So the square root of x plus 2 squared is just x plus 2. And then, well, 3 squared is 9, so that's just minus 9. Which is nice because that is now just x plus, not plus, I'm sorry, minus 7. I could do math. So this is saying now that our numerators, when I multiply the square root of x plus 2 minus 3 times its conjugate, which is the square root of x plus 2 plus 3, that after you multiply them out and simplify, you're going to be left with solely x minus 7, which is great news because notice on top, and if it helps you, you can do parentheses. On top, we have x minus 7, and on bottom, we have x minus 7. We're now left with the limit as x approaches 7 of 1 over the root of x plus 2 Oh, that's a big square root sign. Make that smaller. Plus 3, which is great news because if I was to plug in 7 now, life would be good and great because 7 plus 2 is 9, and we know that the square root of 9 is 3, which would lead me to say that the limit as x approaches 7 of that rational would be 1 over 9. Biggest thing here again is that first initial step. You have to multiply by the conjugate. From there, it's just relying on your algebra. And again, you'll notice here for a lot of calculus that you do, it's going to be maybe do some kind of rule for calculus and then just rely on your algebra skills, your manipulation of variables, your multiplying, dividing, knowing you can factor and you can cancel some stuff out. So we'll see a very similar one next. And if it helps you, pause the video. Try this one by yourself to see if you feel confident on it. Okay? Thank you for pausing the video. And if it helps you, I will tell you that a squared minus b squared is a plus b times a minus b. So with this here, again, we will multiply by our conjugate. Square root of 3x plus 4 plus x over, well, I'm not sure why I'm multiplying by that. We're multiplying by value of 1 plus x. Perfect. So with this here, again, please don't forget your limit sign. The bottom, I'm just going to leave it alone. I'll say 4 minus x and leave that as 3x plus 4. I always make that square root sign so big, don't I? I wish I had just had a pencil so I didn't have to rewrite the whole thing. I never learned my lesson. The top part. I'll work the top part down here below. Again, we know that this first one is our a value, and the second one, which is just x, is going to be our b value. So that is a squared minus b squared. And be careful not to take up too much space here. So that first part, we know the square root of 3x plus 4 squared is just going to be 3x plus 4. And that's minus x squared. So with that, that is now our numerator. So we'll place that up top, negative x squared plus 3x plus 4. Now, when learning factoring, and I'm going to go ahead and erase that because I want to need some more room here, just because I write big on the screen. With factoring, you always want to factor out any greatest common factor, and it always helps to have your a value be a positive number. So yeah, we need to factor in our numerator, but our a value is negative. Not a big fan of that, are we? So let's rewrite this real quick. Again, our bottom, that's a very long division bar. Our bottom's still the same. That's 4 minus x and a square root of 3x plus 4 plus x. But for the top, I'll just go ahead and factor out negative. I'll say x squared minus 3x minus 4. It'll make the factoring less confusing, especially if you've never really learned how to factor with an a value being negative. We tend to teach it, us being teachers, as having a positive a value, which is fine because, again, if you don't know how to factor, we have resources. If you do know how to factor, you're in for a lucky day. You're in for your lucky day here. And with this here, again, two numbers that multiply by negative 4, but when add up to be negative 3. X plus 1. And then on bottom is 4 minus x, square root of 3x plus 4 plus x. Sorry for that edit there. So on the surface, it doesn't really look like we could do too much. If you wanted to, you could multiply your denominator out and expand it. but that's not going to help you. But if you look carefully, notice this first term is x minus 4. On this and this term on bottom is 4 minus x. So we can work with that. So I will do this work on the side, and actually I'll do it up here. So that 4 minus x, I want to somehow make that x minus 4. So I'm going to need to flip some signs here. So if I was to factor out a negative there, I could say that is now negative 4 plus x, which is now the same thing as x minus 4, which is great news, right? Because if I was to make sure I have my limit sign, but if I was to make sure and rewrite this carefully, I would end up with an x minus 4. And yes, I still have that mess on bottom, but that's fine. That's fine to have that mess on bottom, because once I cancel my x minus 4, and then it's a negative 1 on top and negative 1 on bottom, so that just becomes positive. Or you can cancel that out as well. I'm left with just the limit as x approaches 4 of x plus 1 over square root of 3x plus 4 plus x. Now, before we try to kind of like work this out a little bit more, let's just make sure that if I evaluate my limit here, I don't get 0 in my denominator. Because if I don't get 0, I don't need to keep multiplying. I can just kind of call it quits here. So with this here, if I was to plug in 0, on the bottom we'll get 3 times 4, which is 12. 12 plus 4, which is 16. The square root of 16 is 4. Life's good. Life's great. Go ahead and evaluate your limits. Again, if we evaluate a limit and we don't get 0 on bottom, quit working. Quit working and just get your final answer. Again, this now becomes 16 plus 4. So while this answer may not be ideal, it's a number. It's a lot better than what we started with. So biggest thing here, multiplying by conjugate is another method we learned on how to evaluate limits of rational functions. And then with that there, seeing the biggest struggle probably for some people will be this part right here. So multiplying these two, making sure that if you have multiple terms within your b, make sure to distribute that negative. That's a hint. So this was a little quick review video. We'll still do some review in class on Thursday. But after that, if you have any questions, please let me know. I want you to do well in this post-test. But if you don't have any questions, man, I will see y'all in class on Thursday.